All right. Good morning, everybody, and thanks for coming. We've got an action-packed webinar today on our roundtable for retail fraud and how graph and machine learning can help. A couple of quick early items. Number one is we're recording today's session. So if there's other folks, other practitioners, interested team members, certainly pass this along, and we'll be sharing this again probably on Friday. The other thing is at the end of today's session, there's a Q&A chat box at the bottom of your screen. We're going to leave some time for questions, and we want to definitely get those answered for you. Without further ado, we've got a really good lineup. We're going to talk a little bit today, if you followed us on what we've been doing in fraud. Tigergraph and Expero have been sharing lots of different kinds or flavors of fraud and how we approach that. Today's speakers, we've got Michael Shaler and Victor Lee from Tigergraph, and then myself, I'm Scott Heath, and Graham Gansel from Expero. Our first speaker will be Michael, and again, our goal today is to show you a little bit of why retail and graph are so interesting together, how we approach those, and then the second element is we're going to give you some real world examples, and then I'm going to give you some live demos. So with that, we'll go ahead and jump right in. And our first speaker then is Michael Shaler.
Thank you so much, Scott. It's a pleasure to speak to everyone. Good morning, good afternoon, good evening, wherever you are. And that's probably a good jumping off point for kind of what the challenge is with retail and how to prevent fraud in that context. We're going to talk about that, but let's put this frame this from the context of, graph analytics are a great way to look at things differently, but let's double click on this for a second. Next slide. We're not talking about just graph analytics, but in graph analytics, in database analytics, we're talking about transactions, with the flow of commerce through the various channels, visualization, and Graham in particular is going to talk about the artificial intelligence, machine learning angle at scale. So we're going to go ahead and dig in a little bit deeper right now. Next slide, please. So one of the things that we're really seeing more and more is that while many companies have an omni-channel or cross-channel customer journey, what they don't have is an approach to understanding how those different channels may interact, and more specifically, how fraudsters may interact across all those channels. And to borrow a phrase from the security world, we're really talking about advanced persistent threats everywhere. Every customer contact point, every point of sale, every touch point in the entire customer journey is ripe for fraud. And one of the things I see or I hear from customers is that while they have a great set of touch points for customers, they don't have a great set of protection touch points. They can't necessarily coordinate as effectively and as in such an integrated fashion as their adversaries on the other side of the line. And so fraud is becoming increasingly more coordinated, organized, and adaptive. And the challenge here is not just getting the bad guys, but hurting the good guys. As fraud accelerates, let's go back, please, Scott. Sorry. So as we, if you're trying to chase down fraud hard, you run the risk of creating more false positives, and that means that customer satisfaction is going to really dramatically decrease. Customers want to be able to buy and want to be able to understand what they're buying and how they can do it. So, and then, finally, we see a lot of changes in the regulatory environment around payments in Canada, in Europe, and elsewhere. And so one of the things that's so interesting is that we're seeing a change from 2014 to 2018, how much more, we're starting to see an increase in account takeover and new account fraud. But, the card not present, at point of sale is a big challenge, but we're going to see even more sophisticated approaches. And so retail fraud, becomes not just a money laundering consideration, but also, how, our credit card fraud and consumer credit is becoming amazingly large and a huge threat to the business as a whole for retail. Next slide, please. So retail fraud is all about deep links and relationships and patterns of behavior. And understand that in space and time is absolutely critical. From the customer point of view, we have all these vertices, these edges and graph terms. What that means is we have entities that have relationships, and we can then make, understand how that all connects to drive product recommendations, what the customer journey is going to look like, how do we optimize for similarity between customers. Learning from other customers is very, very powerful, but also learning what fraudsters are doing. So we have the chance to do both about that. In terms of the transactions, obviously we have all the payment mechanisms, all the accounts, all the network data that we can access. But then we also have actors, owners, and transaction details on the edges there that connect those patterns of behavior. In terms of the analytics, we can do community detection, we can do pattern matching, and who is a good actor and who is a bad actor. And the summary is that we can really, really understand, the power of relationships between people, businesses, and associations. And we can understand the different touch points that connect those through phone, email, and other connections. In summary, we have a way to understand the history of connections to fraud and then predict fraud based on that. And then we can actually optimize likely transactions that are going to be vulnerable to fraud. So we actually have a holistic view of what we can do to prevent retail fraud. Next slide, please. Now, in the real world, it's messy. In the tabular world, it's not as messy, but boy, there's a lot of context that gets lost in the process. And this is a slide by Gartner. And what's interesting to me is that we think about how the world is connected and how we model that. And it doesn't tie nicely, neatly to a relational database table. We need to understand, we need to have a model that preserves the connections between entities and relationships. And that's what Gartner means by multi-context. Graph analytics are the best tool for doing that. Next slide. So my next guest needs no introduction, but also here are some top 6 reasons that retails are so hard, especially in the retail context. So we have lots of signals, we have hidden dependencies, we have time creation, we have to do risk scoring, and we have to make sense of it all. The volume of data is immense, and then the real-time nature of this is very, very complex. You can't get this done without having a sense of connected data. You can't have you can't actually rely on just humans. You need to do machine learning, and the visualization is so important. Next slide. So here's a great example of a retail fraud. Let's just say we're trying to understand how people buy phones and how people use phones to understand, to behave as good retail purchasers, and then how to understand what might be a good phone and a bad phone. And this is just looking at behavior in terms of how people call and then how people connect to retailers. So you have these good phone features. Grant's going to talk about this in detail in terms of how feature generation inside of Graph, feeds machine learning, and it feeds Graph database insights and analytics that are unique. So you can't do this all with rule-based systems. Traditional education systems are fairly static. They don't understand patterns of behavior and connectivity, and they don't really have a way to map behavior in time and space in a connected manner that gives the insights that we need to prevent retail fraud. Next slide, please. In terms of what we're doing together with Expero, we're building out a set of visualization and development toolkits, and we're really excited about this. This is just really, really breakthrough stuff. We are so pleased to be able to actually take not just what there's other graph visualization systems out there, but we're building out together our specific supply chain, fraud prevention, and customer 360 toolkits that have depth and breadth inside of them in terms of being able to incorporate not just beautiful visualization and great complex user experience, simplified and really empowering workflow to do investigations and to prevent fraud, but also to add machine learning and other and algorithmic capabilities to the graph and its representation in ways that are truly unique in the industry, we think. So we're really excited to be working together at Expero on these visualization toolkits. Next slide, please. So why is this necessary? So we're all spoiled by Google and having a 200 millisecond response time on search. And so that's kind of where expectations are. And when we think about how consumers are thinking about their relationship with businesses, those expectations have never been higher. And then on the business side, reputational and operational risk has never been higher. We've seen recently very large banks having to pay extraordinary fees, hundreds of millions of dollars, because they didn't have the controls or the analytics they needed to be able to intercept the risk of fraud and what that could mean to their customers and to their reputation as well. The next risk is obviously, as usual, business as usual is kind of, we need to make more money at lower cost with lower risk. And how do you drive that with higher customers? It's never been more difficult. And then obviously, as I mentioned before, we have these, the potential of fines that could actually be very, very damaging. And what that could mean in the big picture is it's a huge reputational and governance risk. In terms of the rewards, we need to do this now because it can be fast to deploy, and you can actually make a big difference in terms of how we intercept retail fraud and how we prevent it. And it can be much more effective than traditional systems, especially when you combine graph with machine learning. It boosts the correctness of those answers and it empowers insights that are very, very powerful. So, the reward is that your customers and your business will both do better by detecting and preventing fraud. That is compelling and standalone reason to get started as is. But then we can actually, the wonderful thing here is that we can leverage current technology and approach and augment it with higher accuracy and lower false positives. So you don't have to rip and replace. You don't have to get rid of anything today. What you can do is leverage what you already have learned from your current traditional and legacy education systems to achieve better outcomes and better results. Next slide, please. All right, so over to you, Scott, please.
You bet. Well, so Michael's really set the table for us, and I think what we want to do now is let's take a walk. Let's look at these different ingredients as we step into that. And I think, over on the left, we see these use cases, right? Which is, retail fraud can come from a number of different ways. It could be an internal group. We're working with an external group. Could be rings or groups of people. It could be, just simply falsified individual credit card or transactional level ones. In some cases, these bad guys are using false credit cards to get false IDs, and then they're actually buying our retail goods and services, and we're out sort of holding on the wire. Now, our partner, the credit card, is trying to do the same thing, but down here, when you look at the IoT and the device level, that becomes very important in how we start to investigate these, because if they've done a good job faking us out, they can get through us, the vendor who's selling a retail product or service, and then the bank and we are sort of stuck holding the bag down here in claims and disputes. And then ultimately, what do you do if you are a retail vendor and you need to prosecute? How do you build the case? And how do you do those things? And that really sets the more finite table that Michael laid out for us then is, why do you need a graph database? Why do you need machine learning? And why do you need visualization? And the three constructs that we have here are those three elements that we can start to see. So give a human easy visualization, show it in 2 or 3 different ways. Show me how things map together, show me where these come together, and how can I investigate fast and easily, and quite frankly, stop those credit card transactions or purchases that are coming through. And then I use what's over in the right. And this is where Victor and Graham are going to walk us through. How do we use those things to predict, avoid, and do it in real time to go do that? So this just gives us a different sort of inverted tree. It's sort of a graph, if you will, of the use case. But the other element that we typically see is whether we're in the bank on the one side of retail fraud, or we're actually the retail provider of goods and services, these things all link together. These things are many times either blast radius separated, or I need to go in and connect the dots. So maybe somebody stole my laptop purchase online, and they stole a synthetic ID and many other kinds of things. This shows now that the Tigergraph, the power of Tigergraph and Expero is the ability to connect them or separate them with these dotted lines or straight lines. And what Graham and Victor are going to show us is data science is great, and lots of machine learning has given rise now. The big takeaway here is that it's not the data science that's so hard, it's this reproducible and scalable version. And that is really very difficult when you're looking at billions of transactions for purchases a day, and you're looking at all those kinds of things. How do you do that at scale? How do you allow one group of investigators who may be junior and another group of investigators that are senior? How do you put them on the same level? How do you get that indication in real time or milliseconds is really sort of the core problem that we'll be diving into as well. And then ultimately, we'll see more on this again later, but really it's this beautiful joining now of graph algorithms that are easy, they're in the box. Tigergraph provides these to you. And then tried and true machine learning. Maybe you already have a lot of machine learning, and many of our customers do, but how do you join these together to go that extra mile for prevention? And now let's look at what are examples. Now, fraud is strangely, even though it's retail fraud or AML, we like to segment those. But what we start to see now is over here on the left, this is a retail manufacturer. This is a real example. And we found almost a 10% increase. And Graham's going to walk us through how we were able to do that in this combination of graph, machine learning, and existing systems. And then you can see a very similar kind of analogy in other kinds of fraud, which is claims fraud elsewhere. And we have lots of examples, but the point of this is real. The numbers are accurate, and they're getting even better over time as knowledge graphs start to expand and show better relationships. They can get even better. And that really brings us to our next one, which is the demonstrations that I'm about to show you are really in this fraud investigation and stopping tree, if you will, which is we start at the top. Executives are really more about that in that previous flow chart of the tree of pain. The executives want to see, where are the attacks coming from? Are they going after certain product lines? Are the retail locations under duress? But where is it coming from? They have the ability to drive in. Then you see our next person who may be line of business. Maybe it's a certain laptop, or maybe it's a certain TV, or a certain category of thing that we want to see. Is it perhaps connected to internal or external? Are there regionalities that go on? How am I doing for different kinds of customer service reps? What are the different things that I can dig in on now to say, in my line of business, how am I managing what that fraud may look like? Then you may even have a customer facing. You probably already have a customer 360 application. If you don't, certainly come to one of our webinars on how you can use Graph for that. But how do I now interact with the customer? How do I say, look, your purchase has been denied, or it's on hold? How do I do that in a real-time manner? How do I suggest alternatives to keep customer satisfaction high, and then alerts and updates? But then we get to what we'll show here in a minute is the team investigation. So how do I find it and stop it, and how do I then actually do the next couple of layers, which is down in the analytics? I need to create certain scenarios or recipes of machine learning and graph algorithms to detect it, find it, and stop it. But this is now my lab down here in this analytics user. And then finally, we get to our friend Tigergraph. The tool itself is fantastic. It's built for a super user, and how I built these data models and how I can manage this in real time. And this whole stack of users now will become very important because depending on where you're touching this elephant, if you will, your visualization and your role for what you need to see is very different. And that really gives rise to what Michael mentioned around these toolkits. The toolkits are designed really for all of these different team members, if you will, so that we can build a cohesive workflow. The other thing then is in this process. So whether I'm finding it today and I use a product like CyberSource or Actimize, That's okay. Many of our customers use those as signals. What we're going to show you today then will allow you to stand on top of that and make it even better in this case management, the documentation, the prevention, and then basically teaching the system to learn as well as the humans, and even perhaps going into the next step of prosecution. How do we make these steps both seamless, fast, and at scale is what we'll see here in a minute. The next thing is for those of you that are technical, what is this logical flow, right? So when we connect to a cyber source, or we connect to an Oracle, or we connect to the data, we have multiple options. And as the team walks through this now, we can connect all of the data, right? So we can look for similarities and these kinds of things. This is a little different than what you might find in a standard connection or interface here, because things that we care about in fraud may not be what we care about in customer 360. And so this data mapping and this integration here with entity resolution inside of Tigergraph matter greatly. So multiple addresses, multiple cell phones are something that we may filter out traditionally, but in a fraud analysis in a graph database, those are very important. Those can tell us things about either accuracy or potential of fraud. Not having an email for more than a day and not having any verified online social media accounts is a problem. Having 12 phone numbers versus 0 phone numbers can both indicate fraud. So this data mapping as we get into the graph can be very important. And then obviously we're going to talk about how the graph works, and then how we query that, and then obviously visualize it. But this is a great sort of one-stop here. Then we can start to see things like real time. So in this case, we'll see here in a minute, we'll see a live example of this, is what is this system, this recommender or scoring or rescoring system that Tigergraph can do? We make a quick 30 millisecond recommendation to a user. You should reject this. We're using other signals like Actimize, or if you don't have Actimize, we can use internal systems, or if you don't have any system, we can be the system. But the goal here is to give the human a very quick look and say, you should do this, and I can then tell you why. So as you open up a transaction or see the connections, now I can start to do this collaboration. As an investigator, and that's sort of step 2, is now if it's been quarantined, I can look for similar patterns, I can look for investigations, I can integrate things like Python and Jupyter notebooks with machine learning. Then I can see what were the timelines. So the human can actually take all this great information out of Tigergraph and see it sequentially. I can actually see when things happened and see, there was, in this case, failed logon attempts. Somebody was trying to perhaps use a cyber connection as they got into the details here, and then perhaps they stole my good or service as they go through that. Geospatial, where did things happen? So there may be a gang attack on your credit card in a certain area, et cetera. And then finally, how do we use Tigergraph to train and relearn? We'll see that here in a moment. So as we go into that now what I'd like to do is actually give you a couple of live examples. In my first example, I am a frontline transaction, basically either somebody in a customer service role or someone who's watching transactions happen for my good or service. I could be selling software, I could be selling TVs or laptops or whatever it may be. And the point here now is that I, in this system, can actually see a quick approval. I can see what the human was going to do, and then I can see either order and merchant information. Well, this shows me here, well, maybe I want to dig in on one of these, right? I can actually go look at one of these elements and I can say, well, show me why you did this. Well, in this case, I have one email that was linked to someone who was known to be fraudulent. I have phone number and then perhaps even visits on my website. So there's attribution or click data. The other thing that I can see is this particular order here looks similar in some ways to other ones, and or I can go do that, right? So I can accept this order now. The recommendation here is that I reject it, but now perhaps I want to move into the graph. Now what I can do is I can actually dig in and go look at that, right? And so what I can do now is I can go look at all these different kinds of orders here. I can go look at different combinations of these elements here. I can denoise these by saying, show me what the sessions were. Was I a visitor on the website here? And then I can see interesting things, like I can see where was this session ID? Where was this email and how did it link? And as I zoom in on these things, I can actually color things, right? I can say color these in different ways. I can say things that are suspicious, things that are not suspicious. And I can see in this case, I actually have 2 sessions and 2 transactions that were linked, and I have multiple visit IDs. That can start to tell me of, again, why did I want to reject this, right? Those are the kinds of things that I can do. In this case now, I can actually show it in a different or linear way. I can see it in more of a hierarchy. But again, these are ways that we use for different users to come in and interact with the data where we started. So that's one vignette. So this is someone who may be a transaction investigator, or someone who actually wants to dig in or needs to approve these in real time. The second version is more of a collaborative version that's now a bit more extensive. In this case, I actually want to look for trends in other transactions. So I can actually grab what seemingly could be random transactions that are coming in. And in this case, I may be looking at multiple versions where I may have a time component, which I see down here at the bottom. I can see where these perhaps fraudulent transactions are going. And now what I'm doing is I'm looking for a bigger crime network. And in this case, again, all I do is double click. I can see where this transaction came from. I can see that this person was actually using a corporate credit card. And I can start to see now this larger expanse of, well, there are multiple transactions. There are multiple connections as I step into this. And now what I can do is I can actually save this for an investigation, right? So now what I've done is I've been able to do that. Now, I also have the ability to do something that we talked about previously, which is show me the geo in the map. Show me where these things are occurring. Show me what are good and bad transactions as an overlay. I also have the ability to just do simple search. So in this case, I can actually come over here and say, well, I really don't want to care about this particular transaction. I'm going to gray that one out. And perhaps I don't want to see this one as well. And what I'm doing now is I have the ability with the toolkit, as you see here, is I have the ability to create these partitions and see the data in different ways. So what I'm doing is I'm empowering now this investigator. The third vignette that I'll show you is more of that executive dashboard. Now I can see things at a glance. I can see things like alerts. I can see other kinds of transactional capabilities here. I can see heat maps and regions. I can see what's going on, et cetera. And so now what I have the ability to do for an executive is roll up all that great information that's in the graph, show me those investigations that are complex and deep, but give it to me in a very simple way. And the goal of, again, this sort of toolkit, if you will, is to allow lay customers, end users, et cetera. And then more importantly, with the Tigergraph toolkit is put the power in our customers' hands. So you can either custom build these solutions on your own, but now you can spend your time building these applications much faster. So with that, I will pass the ball to Mr. Gansel.
Thank you, Scott, and thanks for the intro earlier, Michael. Before I jump into the topics today, I just want to mention that if you want to see this stuff in its detail, feel free to head over to our blog page, because we have most of the things I'm going to talk about today detailed out with technical specifics over there. So let's begin by talking about why you need to use graph plus machine learning. We find, as Scott mentioned earlier, that increasing accuracy is significant when you use the combination of two systems. Because fraud detection systems are often in place already, you can use the current technology you have in-house. And when you do, you can decrease false positives in addition to increasing accuracy, which helps decrease the burden on users. We also see an increase in speed and efficiency, of course, because we're using that combo system. And the beauty of integrating machine learning with your graph is that it can adapt to changes and improve over time when you include the humans in the loop type of system that I'll talk about today. When you do this stuff, you see an increase in accuracy. And what we're showing here is tried and true percentages for what we have observed in the marketplace. So what you have in place today, the traditional fraud detection tools are in orange. When we add graph, those graph machine learning algorithms, which I'll discuss later, we see a relatively high increase in accuracy. And then as time goes on, when you integrate your human in the loop feedback, which I'll discuss in detail, we find that accuracy continues to improve over time, and it is also significant as time goes on. So let's look at how all these things fit together. We have our source data coming in from various sources that exist already today. We map those data sources into a format that we want to integrate into our graph-based systems. We then resolve those entities because we want to make sure that we have contiguous connections between, let's say, people and companies, transactions, bank accounts, et cetera, and inject those into our graph-based system. And that is the point at which we jump into the deep fraud analytics. This is how we design our fraud detection system. Again, this is the combination system of graph and machine learning. What we see here is at the top of the slide, a combination of various systems performing fraud detection. Some of those, I have 3 boxes here, but it could be as many as you have in your company already, plus our 2 add-ons. So if you already have a fraud detection system in place, we want to augment that system. We want to make that system better using our statistical model with machine learning and our graph-based model. When we combine all of those things using our composite risk scoring system, which is what machine learning specialists would call a meta model, we're able to score the entire pipeline against historical data to make sure that we're conforming accurately to the behaviors that the company wants to optimize for. And of course, that could be dollars saved, dollars walking out the door in fraud. It could be things like overburden to the fraud analysts, or it could be a combination of many different factors, which of course we know it always is. The beauty of this system, of course, is integrating humans in the loop using our explainable AI framework. I'll go through those details in the future, but the overall system ingests information seamlessly back from fraud analysts by suggesting and highlighting to those analysts in real time in a UI why the system is making the decisions it's making. So I'll go through all those details, but first let me just jump into the actual analytics and show you how this stuff works. This is a high-level overview of what we do in all of our systems that include graph and ML, fraud being one. So we start with our graph of known entities, and we intelligently extract subgraphs from the overall graph to build feature vectors, which go into our graph-based machine learning algorithm, which we're showing down there in number 4. And how this works is it analyzes both the entity properties. So for instance, that would be things like bank, like the bank identification of the credit card used in the transaction, with the actual connection information to other entities in the graph. So for instance, how many hops away is the nearest known occurrence of fraud in the graph? And of course, at the end of the day, we manifest this by highlighting this information in a usable way to users in the dashboards that Scott showed earlier. So we have an output on the next slide of the actual TensorFlow output that we've used in a system like this. So Scott, you can go ahead and click the next slide. This is a TensorFlow diagram showing the neural network that we've used to do the actual fraud detection course. And as I mentioned earlier, jump into our blogs if you're interested in the technical specifics and nitty-gritty. But I also wanted to showcase on the next slide the behavior that we see in the graph. And this is really the power of combining graph-based analytics with machine learning-based analytics, right? So we can cluster our known entities, again, this comes from historical transaction data, into groups of behavioral conditions for our known, let's say, entities, right? That could be companies or it could be individuals. And when we do that, we're able to inject those graph-based measures I just mentioned into the machine learning algorithms. And importantly, if a fraud investigator is interested in the actual connections and low-level information about why those transactions or entities are related, as I'm sure they always are, they can dig into the graph in detail through our system, which Scott showed earlier, and I'll show you how that works here momentarily. So let me jump into the aspects of human in the loop. The beauty of building a system like this, which responds to fraud investigator feedback, is that both the system and the analyst learn together in real time. So as I'll show, we will highlight the explanatory reasoning behind a fraud flag to the user. And that user can make decisions or ignore or choose not to make decisions based on those explanations, whether that fraud highlight, that flag was correct or not, and why was that flag correct or incorrect. And as they do that, you can see here, those explanations change, which helps both the system learn, and it also helps the analyst learn simultaneously. And here's an example of that. So what we're showing is on the upper right-hand corner, we're surfacing a fraud flag on a claim or transaction to that analyst. That analyst can indeed choose, in the lower right-hand corner, can indeed choose just to ignore that recommendation, and we would go on with our day and the system would continue performing. But they can also choose to give the system some feedback, right? And that feedback comes in one of two forms. It could be, nope, you're wrong, or whatever, you're right. Or it could be some explanation about, let's say, why the system was wrong. So there are two tracks here, a manual and an automated track, that improve the system. The automated track is indeed fully automated. It's built with an automated retraining pipeline of your machine learning system, which can augment your existing system using our fraud detection model with Graph, to be able to adapt to changes in, let's say, fraudster behavior, right? We know this happens all the time. As soon as a fraudster understands what things flag them as fraud, they will change their behavior. And using this system, we have our fraud analysts assist the system in detecting that change in behavior. Of course, that model is then retrained and deployed to the user interface, and the cycle goes on and on and on across time. What this looks like in the UI on the next slide is the actual surfacing in the lower left-hand corner of explanatory reasoning. And what we're showing there, sorry for the small text, is, of course, the reasons, the top suspicious signals, why we think a transaction may be fraudulent, and then diving deeper into that transaction. If an analyst wants to do this, of course, they can choose not to do it. They can jump into the graph-based view and see the explanatory reasoning as it relates to the entity connections. And then, as we show on the right-hand side, again, if the analyst chooses to, they can tell us why the fraud flag was correct or incorrect, or what reasoning they would have chosen to make that decision. And this, on the next slide, what we're showing is exactly the same thing. I've just bubbled it up here to the high level. And what we see is on the left-hand side, a full transaction list with the recommendations generated by our system, and alongside the reviewer decisions, the investigator decisions. And on the right-hand side, of course, that geospatial view, which has explanatory reasoning. So you get the high level and you get the low level if your analysts decide they want to dig in. So these are generated, diving back into the technical specifics, the explanations are generated using a variety of different methodologies, all of which we have here at Expero as parts of what we integrate into these systems. And technical specialists on the call may recognize some of these types of systems, and others, just to keep it at the high level, I'll say, these types of explanatory reasoning work in the individual case, like on a per transaction basis, and they also work on an aggregate basis. And we use those graph-based features to highlight, as Michael was saying earlier, the pattern-based recognition of those fraud characteristics. Again, our goal here is to help fraud analysts discover not only fraud, but behaviors of fraud so they can catch fraudsters in a proactive posture in the future as those fraudsters change their behavior. One other thing I'll mention before I showcase how all these systems fit together and then hand it off to Victor is that if we require our fraud analysts or maybe our data science team to integrate, routinely integrate new types of analysis, we also have a notebook integration component, which allows, let's say, someone like a level 1 fraud analyst to push their view to a data scientist or to a deep analytics specialist to generate a new type of algorithm, which that persona can then push back to the screen for the level 1 analysts to then use in the future. So let me wrap up by saying here how all the pieces fit together, and then summarize with a nice crystallized view. We have Tigergraph integrations to our both components of the detection pipeline. So that's the training, offline training component where your data scientists are interacting and making their models. And the inference time components, which is the real-time production systems that operate across all of your systems and again, augment those systems. Only important thing to note here from a non-technical perspective is that indeed these two systems, the training and the inference systems, are completely independent, and they are they work in parallel so that they are fully adaptive across time as business operations change. So let me wrap it up by showing you how what we've done here, what we've talked about. We have 4 major components that are related to any graph machine learning system, specifically fraud in this case. We must monitor the results, the output of our system to understand how that system performs as it moves on in streaming time. We have a CI/CD set of tools to deploy new models, machine learning models in real time, which integrates with our active learning components. That's what we talked about with the human in the loop versioning and updates of that system. And then as we've shown, we have the interpretability components, those explanatory reasons for why fraud flags were generated. And I encourage folks to go over to the data products web pages on our website to see how each one of these 4 operates in great detail. So that's it for me. I'll hand it over to Victor. Thanks, everybody.
Thank you, Graham. So you've heard a lot from the previous 3 speakers. From Michael, he talked about the importance and the power and the necessity of using graph today to combat the really huge problem of fraud, which is only becoming a bigger problem. But this is actually a nice match between a problem and a solution technology and a solution approach, because both of them deal with doing transactional things, connecting the dots, hiding things deeply, but then digging deeper to uncover them. So the fraud depends on doing things in a pattern, and then you use graph to find the pattern. So it's actually a nice solution that fits the problem. Scott talked a lot about the use cases, going into talking about different types of fraud and different ways that they affect an organization and different ways that you can approach solving it, particularly from different levels of visualization. And Graham, as being a machine learning practitioner and expert, really went into some of the specific techniques and workflows that you can use. So I'm going to try not to add a whole lot more because you already have a lot of information. I'm going to try to talk about, okay, you want to get started. So how can we do this? I'm going to try to give you a pretty simple map for a road to success. You've got your data sources. You want to bring them into a graph. And we often call this a 360 graph because you're merging multiple sources. It's giving you a larger, more holistic view of your environment. The second phase is you may want to and this is optional, but for example, you've got human users or human customers coming from multiple sources. They may be represented in different ways in the different data sets. The same person may have a slightly different name, or they may have multiple addresses or multiple emails. You may want to do some so-called entity resolution to figure out who are these persons or these companies or these products are in fact the same thing. That's sort of cleaning your data. And there are some rule-based approaches, there are some machine learning-based approaches, and that's a whole separate topic, which we're not going to talk about in detail today, but we can talk about some other time. Then you want to start to, you've now got your data, you want to have some initial visualization to do both some human exploration as well as some unsupervised machine learning, which is going to get you more familiar with your data. This may be the first time you've seen all this data together as a graph. Just doing some exploration, both manually and by running some traditional graph algorithms which characterize your data to see connections, groupings, frequent patterns, outliers. You'll become more familiar with your data even when you haven't done any fraud detection or machine learning, supervised machine learning yet. And then you want to get to, while you want to do this, your fraud prevention and detection. And as Graham mentioned, you want to extract graph features, and there are a number of ways you can do this. There are some automated approaches for extracting small graph patterns. You can do it holistically for the entire graph. You can take sort of this hands-off approach of transforming the entire graph into a set of features called graph embedding. You can run graph algorithms, and you can run targeted patterns based on your understanding of your application domain. So it's not an either or necessarily. You may want to mix some graph algorithms with some domain specific patterns. Then you need to have some training data, right? Some historical cases where this was fraud. So we can associate, excuse me, these conditions or these features then turns into this type of fraud. And now you're ready to run your machine learning. And then you have two basic choices of either, as we've mostly talked about today, of using a traditional existing external machining platform. And perhaps after you become familiar with that, consider going another step and looking at in-graph machine learning. And I'll talk about that next on the next couple slides. Excuse me. First, I want to just say a few things about graph algorithms. There are dozens, scores of standard graph algorithms, which mathematicians and computer scientists have developed over the decades. And, just like any graph vendor, Tigergraph has a library of graph algorithms. But the nice thing about ours is they're written in our regular query language. They're open source, so you can see exactly how we do things, and you can modify them. You can adjust them, add parameters, modify the output slightly, add some conditions to really do exactly what you want. And well, they perform particularly well because of the way the Tigergraph engine is written and the way the GSQL language coordinates with the engine to give you high performance, parallel, scalable performance with accumulators, which are, without getting to a lot of detail, any statistical work is going to want to use accumulators, and they are a built-in feature in Tigergraph. On the next slide, I kind of go into, again, the first of your two choices, and Graham talked about this already, and this is where you develop your graph features, and then you export your graph data into your existing machine learning platform. And this is the easiest way to integrate graph into your existing workflow to improve the fraud detection that you already have, to get some additional lift there. And the advantage is this is easy, and it's using your existing machine learning infrastructure. On the next slide, I talk about the approach. I don't have a picture because it's actually pretty straightforward. You have your graph, you extract some features, and they decorate the data. They enrich the data that you have in the graph. And then you just run the machine learning right there. And the advantage is you only have one system there. All the data is available to you. So you don't have to select which data will I use. You just have all of it at your disposal. And you don't have to set up a pipeline to export and import and to deal with that delay. Now, there are some additional things you have to look at, whether this is really the right platform. Usually you need scale for machine learning, big data and predictive analytics. When we first started using the term big data, maybe 15 years ago, and he talked about the 3 or 4 V's: volume, variety, velocity. Maybe there was some optional 4th V's, but you need to have enough cases and enough variety of cases so that the system can see the patterns. If you don't have enough examples, or if all the examples are the same, it's not really going to be able to learn. And so having enough data and enough of the right type of data is important for successful machine learning. And that's one reason why graph is so valuable, is because it actually provides this density of information with adding not just the data entities, but the connections between them, that gives you sort of a more bang for the buck. You also need to be able to run the machine learning algorithms themselves on the platform. So the engine really has to be appropriate. Does it perform machine learning type algorithms? Does it do it with parallel processing? And it does have it built-in parallel accumulation. So those are all address the expressibility of what you want to do and the performance. So not every graph database platform is going to be appropriate for in-graph machine learning. We think Tigergraph is. In the next slide, kind of go into, again, I'm not going to spend too much time on this because I've already mentioned some of it, but those characteristics of Tigergraph enable you to do what we call deep link pattern discovery in real time or near real time to look many hops deep, 5 hops, 10 hops. And again, because fraudsters try to hide their tracks, they make it hard to see what they're doing. And you have to be able to dig deep, and you have to be able to dig deep quickly through a large amount of data to trace what they're doing. And again, as we talked about the need for large scale, not only because if you are running a large business, if you have a national, international business online with maybe, it could be anywhere from thousands to millions of transactions per day, thousands to millions of customers, you may have a large to extremely large data set. So you need to be able to handle massive scale. And again, the ability to really run both the feature extraction and then some of the unsupervised learning and possibly supervised learning in your graph itself, again, requires both an engine and a language that are designed for that. The next slide, I'm going to talk, I'm not going to go into too much detail. This is just sort of talking about the latest updates in Tigergraph. I just want to hit on the themes here, that we're making it easier to use without writing code. That works really well with the Expero approach of providing excellent user interface and visualization. So we're making it easier to develop the application, and they're making it easier to work with the data that you have and to, to query and to see results. And one thing that you noticed from the presentations from Scott and Graham is that just because you have a graph database doesn't mean that you're displaying the graph all the time. You're displaying charts and tables like normal, but the graph, as Graham said, it represents your engine. And it's that engine and that source of richer information that's the real benefit here. We've also made improvements to improve the scale and performance. And then I'm going to want to talk about the things where we've really focused on making the product easier to use for machine learning practitioners and developers. We have an expanding ecosystem of different things around that, including a whole host of integrations with machine learning platforms. And to talk about that and to show that, I'm going to very quickly go into the developers portal. On the next slide, I'm about to wrap up. So we, on our latest website update, we now have a developers page, and there's a link there to our developers portal. Scott, if you click on that link, you see at the top, it's got home, get started, learn, and projects. And we're going to take a 30-second look at the get started. And you see there on the menu on the left, right after it tells you how to, your very first steps with Tigergraph, there's a graph plus machine learning section. And on there are several different, getting started projects for you to see things you can do. And then back, if we go back to the main menu, and then there was projects. And projects also have some machine learning projects. There's some, you see there on the menu on the left. So there are things that Tigergraph alone has been doing. And if you go on the Expero website, you can also see some of the things that they have developed. So both Tigergraph by itself and well enhanced with Expero is giving you there's a lot of existing work that's being done, and there's a lot more that we can do if you. So we can go back to the slides, and I'll just wrap up. So you can skip that. We just showed that. So, we want to help you get more value from your data by leveraging graph to make connections, to find and detect and prevent fraud through this combination of machine learning, explainability, good user human in the loop for detection and tagging and improving the learning, and having the right user interface and the right graph database scalable and operational is going to only help you. So you can get started right now. You could go on Tigergraph Cloud to try Tigergraph, or you can contact one of us to, you can go on our websites to see some demos or contacts any of us. So we're can just go on to the next slides, and we'll just kind of wrap up and say thank you for your time. And we're here to answer any questions you have. So I'm Victor. We had Michael, Scott, and Graham here today. And thank you for your attention. Are there any questions from our attendees?
Yeah, thank you, Victor. You bet. Go ahead and enter those. I see a couple of them here. The first one looks like it may be for you, Victor, which is simply our ML teams are interested in the algorithms on that website you showed. Is there a link or a way to get to the in the box algorithms?
Yeah. So actually we have a documentation website, docs.tigergraph.com, and the graph algorithm library is listed right there. So you can approach it two ways. You can read about what we have, or you can go right to GitHub. There's also a Tigergraph ecosys GitHub repository, which has the graph algorithms there. The easier way may be to search. It may be easier to search the documentation, and that will then point you to GitHub. And we're also when you download our software, we're trying to include the latest graph algorithms there. But since we're always adding more, you can go on GitHub to see what new things have been added.
Okay, great. The next one, Graham, looks like it may be for you, which is in the process that you showed for fraud identification, does the human have to be in the loop, or can it be fully automated where it'll accept or reject without a human?
The system's fully automated. The users can choose to provide feedback or not. More feedback helps the system adapt more quickly. And without feedback, the system still performs just with high accuracy. Yep.
Okay. Looks like we got one more here, which says, let's see, after I identify connected data, this is for you, Victor, how would I do an OLAP and OLTP query? Does Tigergraph handle that as well?
Yeah. So, our GSQL language, you can, because it's Turing complete, you can write any kind of query you want. It could be an OLAP one. We have, like, you can think of our graph algorithms are examples of OLAP queries. Or we could, you can learn and we can help train you to write your own OLAP queries is pretty straightforward. But it's using the same regular syntax that's just part of the GSQL language.
Okay, great. Well, it looks like we're right up on time. Doesn't look like there's any other questions. Thank you, panel, for a great session today. And remember, the session was recorded, and we'll be sending out the session. So please share it with those who might be interested. Thanks, everybody.
Thank you, everyone.